Hello everyone, my dear students of first year. We have learned the concept of rank of matrix and we have solved some examples. Now I just put few examples in front of you. You try to solve it and find the rank of matrix by reducing these matrices into row echelon form, or you may call canonical form. Okay, just like using row operations, reduce this matrix into upper triangular matrix and find the rank of matrix. So I just show you few examples. Instead of reading it, you just uh, by stopping the videos, you can write down these examples and try to solve it. These are much more easier and you can easily find the answers also. So the matrices are there. We will solve few examples here also. So there are 14 examples I put in front of you. You just go through that and try to solve each and every example. In fact, I will provide a hard copy of these examples to you as an exercise or as an homework. You can as a homework and you can solve it. Now I choose two examples for to solve here. Find the rank of matrix. The first example is find the rank of matrix. A is given. First row is 1 2. Our first row is 1 2 minus 1 3. Second row is 3 4 0 minus 1. And third row is minus 1 0 minus 2 7. Minus 1 0 minus 2 7. So these are the three rows and we have to solve this problem. Now what we want this position always 1. It is already there, so no need to make it 1. Use that 1 to make 3 and minus 1 0. So what is my first operation here? My first operation is yes, r2 minus 3 r1. And what is the next operation? I have to add minus 1 is there, 1 minus 1 0. So r3 plus r1, right? Correct. These are the two operations we have to perform. So your first row as it is 1 2 minus 1 3. First row as it is. Now 3 minus 3 it is 0. Next one is 4 minus 6. 4 minus 6 it is minus 2. 0 minus minus plus, so it is 3. Minus 3 into minus 1, that is plus 3. Minus 1 minus 9, so I get minus 10. Correct. Last row, addition of these two, 1 minus 1 0. 0 plus 2 it is 2. Then minus 2 minus 1 minus 3. Correct. 7 plus 3, that is 10. Now you observe here, these two rows are almost same, only difference in minus sign. So if I add these two row, I get directly 0. So my next operation is, yes, I am writing this side. What is my next operation? R3 plus R2. So what I get here, R3 plus R2? 1, 2, minus 1, 3. Then 0, minus 2, 3, minus 10. And the last one is 0, 0, 0, 0. If you check 2 minus 2, 0, 3 minus 3, 0, 10 minus 10, 0. So what is the rank of this matrix? There is only one zero row and two non-zero rows are there. Two non-zero rows. So rank of this matrix is rank of A is equal to 2. Understood this? The same way we can solve the next example also. Here, if you see this example, the next example which I choose, here A is equal to 0, 1, minus 3, minus 1, then 1, 0, 1, 1, 3, 1, 0, 2, 1, 1, minus 2, 0. Now here, if I start to solve this example, I want leading element 1. Here it is 0. So interchange first and second row. Here I want 1. Right? So we make that position 1 and then we will start. So here I want 1. What to do for that? Interchange these two rows. Means R1 interchange R2. Correct? Do this operation first and then we will proceed. So do it. I am writing this side so that I can cover everything. Yes, what is my first row? 1 0 1 1. Yes, my first row is 1 0 1 1, then 0 1 minus 3 minus 1, then 3 1 0 2, and 1 1 minus 2 0. Don't worry about how many rows or how many columns are there. Just properly write down it and do your step by step calculation. Now second row already it is 0, right? So no need to make it 0. Now make this 3 0 and 1 0. So what is my next operation? R3 minus 3 R1. So change in R3. Next R4 minus R1. Shall I write here? So here I get 1 0 1 1. Next one is 0 1 minus 3 minus 1. Then 0, this is 0, we have to make it 0. So we make it 0. Then 1 minus 0, that is here 1. Next one is 0 minus 3. So here I get minus 3. 2 here 2 minus 3. So I get minus 1. Last one is 1 1 1 minus 1 0. 1 minus 0 it is 1. Minus 2 minus 1 it is minus 3. Have you get the calculation? Next one is 0 minus 1. So I get minus 1. And if you observe here, these 3 rows are same. So in only one operation we can make it 0. How we are going to make it 0? Keep only one row as it is. We keep second row as it is and we make these rows are 0. So our R3 minus R2, R4 minus R2. Make these two rows 0 and only 2 rows are present. Rank of this matrix is also 2. So our answer is rank of A for the both matrix it is 2. Understood it? Now we'll turn towards our next concept. Same way you can solve these problems which are in front of you. Try to solve it and find a correct answer. Okay? So plenty of examples I keep in front of you. You try one by one and if you are not able to solve then you can ask me. Now next part is if you have understood the row transformation, then we turn towards the column transformation of matrix. So here we have to study the column transformation of matrix. That is also called column as row as well as column. So that is also called as normal form of a matrix. Means we are going to use row as well as column transformation to reduce the matrix, but here in canonical form we reduce the matrix into upper triangular form. Here we have to reduce in the form of identity matrix. R is the identity matrix of order R, right? And 0 is the 0 matrix. Okay, so here identity matrix we have to reduce the given matrix into identity matrix by using row as well as column transformations. Now which are that form? Some matrix we get IR, some matrix we get IR0, then IR0, and last one is IR000. Now what is it? There may be a question in your mind. This is the definition of normal form of matrix. Normal form means these 4 forms. Normal form means these 4 forms are called normal forms. Means how you are going to write the definition? Let A be m by n matrix. Using elementary row or column transformations, we reduce matrix A into IR, IR0, IR0, IR000, where IR is the identity matrix of order R, that is the rank of matrix, and such a form is called normal form of matrix, right? We just take one example for the understanding purpose here. Find the rank of matrix by reducing it into normal form, right? if possible in this space, if it covers, it's okay, otherwise we will solve it separately, no problem. Now by our usual method, this position we want 1, so interchange, we interchange R1 interchange R2, correct. So what I get here, I get 1 1 2 3 5, then 3 2 5 7 12, then 3 3 6 9 15, correct. Now we can make our operation. What is our operation? R2 minus 3R1, R3 minus 3R1. Understood? We have to make these two positions 0. So R2 minus 3R1. Next one is R3 minus 3R1. Understood? That positions we have to make 0. So 1, 1, 2, 3, 5. Then 0, 0. No problem. Then 2 minus 3, it is minus 1. 5 minus 6, again minus 1. 7 minus 9, minus 2. Then 12 minus 15, minus 3. Correct? Then 0, 3 minus 3, 0. Then 3 minus 3, I get 0. 6 minus 6, I get 0. 9 minus 3 into 3, again 9, so it is 0. Then 15 minus 15, it is also 0. Directly we get last row 0. So only 2 rows present, we get the rank of matrix. But this is not the normal form. So to make normal form, I have to make these elements, column wise elements, 0. So use column operation here. So which is our column operation we are going to use here? Yes, C2 minus, yes, I'm writing this matrix again, and just we write the operation C2 minus C1, then C3 minus, yes, C3 minus twice C1, then C4 minus thrice C1, and last one is C5, fifth column, C5 minus 5 C1, correct. And we get 1 minus 1 0. Other elements remains as it is because here 0 in addition, so only these elements 0. So do the calculation and make it 0. So here I get, yes, I remember what was there. Here it is 1 0 0, then 0 0 0 0, because we have to make the operations in that way. Minus 1 minus 1 minus 2 and minus 3, I think, and 0 0 0 0. Now again use column operations. What is the column operation now? Forgot first row. Concentrate on second row. Make it, this position is minus 1, make it 1 by multiplying it minus 1. So you may multiply whole row minus 1 into R2. So what I get? 1 0 0 0 0, then 0 1 1 2 3, then 0 0 0 0 0, correct. Now use column operation. C3 minus C2, C3 minus C2. Next one is C4 minus twice C2. Concentrate on C2 only. Use this one to make the 0. Then C5 minus thrice C2. Right? And which matrix we get? Yes. 1 0 0 0 0 0 1, other 0. You just do your calculation by your own, and if you don't understand, then you can free to ask me, correct. Now I just draw one line here, and I draw one more line here where the identity matrix get end. Last one is there, I draw one line, and bottom also I draw one line. So how many, what is the order of this matrix? It is 2. So I can write this as I2. These are zeros, so I write 0. Then this is 0. Then this is also 0. So I get I2 0 0 0. So this is the normal form of matrix. Now what's happen? Sometimes you may get this another way, IR or IR0, IR0, IR0 0 0, and you just solve few examples and try to find the answers, and just comment in the comment section what is your answer for these matrices, right? So all matrices in front of you, try to solve it, and in next video we will solve some more. Okay, thanks for watching.